analyst. I'm a data scientist. My colleague Lee Robertson is the senior analyst at Public Health Dorset. I'm Ehsan Taati. I'm a PhD student at Bournemouth University, and also I'm working as a data scientist in local authorities, local government, formerly in Dorset Council and currently at Surrey County Council. And a while ago, when I was working at Public Health Dorset, Lee and I collaborated on a project to extract suspected suicide records from the police RDBMS or RMS record management system, and we utilize a large language model and prompt engineering to do that. This is the agenda for my presentation. I'm going to explain the challenge, the drawback in the existing approach, some available solution model and configuration. I'm going to show you the prompt that we use to extract the data, a little bit information about the data, and finding, conclusion, and also the limitation on further work. About the challenge, police, like any other big organization, maintain their occurrences in a record management system. The current approach to identify and extract the relevant records in utilizing query statement to find with similar keywords in the text manually by the operator, writing SQL query, the old SQL query, popular SQL query, utilizing wildcard in the query statement, and reading through the query result to identify whether the returns of the query is related to suspected suicide or not. Here is just I wanted to show you visually what I mean. What's the as-is model is just the operator send the query to the data warehouse, study the result, and iteratively go through this demanding process to identify the keywords suspected suicide records. These are the keywords that they usually use in a query to identify the related records. These keywords may appear in different variations. They might include synonym and similar phrases, and the similar phrases can also have the same meanings, but not exactly with the same wording or spelling. So the keyword search has some drawbacks, including the limited precision. Sometimes it returns, the keyword search returns, the irrelevant result because of the, the ambiguous or, multiple meaning keywords. Also, you need to have the exact match for the keywords. If you have, different variation in a spelling or synonym, it wouldn't get you the precise result. Lack of contextual understanding is another problem. The keyword might have a meaning in different contexts, have different meaning in different contexts, which keyword search overlook it, and also difficulty in long-term queries, which was our case here because we had a long list of suspected suicide or suicide-related keywords. It was a very long-term query, and we had an issue to performing that query. And all of these, including the resource intensity, it's a very, very time-consuming and labor-intensive job to manually identify the relevant records. We reviewed the literature, and to the best of our knowledge, we figured that based on our task, we could have three potential solutions. The first one is natural language inference, which includes the finding the logical relationship between the sentences. For example, if a sentence follows or contradicts or totally is independent from another sentence. The next approach that we reviewed was topic modeling, which is a way to discover hidden topics in a large archive of documents using some unsupervised machine learning models. And finally, making use of large language models and prompt engineering to extract the theme or classes from the documents or the text by prompt engineering. We didn't use topic modeling because we didn't have enough data to fit a. Oh, sorry. Yeah, sorry. Sorry about that. We didn't use topic modeling because we didn't have enough data, to fit a topic model. So we didn't use this approach, and we tested natural language inference, but because we have a large number of, list of the keywords, for doing natural language inference, we didn't use it either, and the result was not very satisfying when the expert reviewed the result. And finally, because of the widespread adoption and ease of use and also the speed of doing inference with a large language model and prompt engineering, we went with this method. We used Llama 2 7 billion parameters, which is an offline transformer-based large language model to extract the suspected suicide record. For choosing this model, we had 3 reasons. First of all, we wouldn't be able to use, the online large language models like ChatGPT due to data privacy and because we didn't want, to disclose any sensitive data. We consulted with the Hugging Face OpenLLM leaderboard, which is a leaderboard that compare different LLMs and their performance for different tasks on the date, and also last but not least the infrastructure limitation that we had in our facilities. In terms of the model configuration, so due to the limited resources, we had to use a lighter version of the Llama 2 7 billion parameters because it's a relatively big, large language model. And yeah, we loaded in 4-bit quantization version. In quantization, usually they shrink the model while maintaining, the similar performance close to the full precision, or maybe half precision F16. And yeah, we used the 4-bit quantized LLM, which only use 4 bits of per weights. Just the next slide is a very dummy and simple example of the quantization. I just wanted to, because it is very important if you have a limited infrastructure and you want to use these offline large language models, you can benefit from quantization, and even with some new approaches, you can load them on the CPU as well. So in the quantization, this is, as I mentioned, it's a very simple example. I simplified it. You have got the original weight in the original weights in the left table, and then if you want to have a quantized weight, you have to have a quantization level or somehow similar to a lookup table. So you find, for example, number 67 in the lookup table and put the equivalent, quantized version of the weights in the new version of the model. The other configuration that we used for this model was, setting temperature to minimum because we wanted to get a realistic result, and These arguments in the large language model controls the model creativity. So we set it to minimum because we didn't want to, reduce the hallucination or maybe some unrealistic results. Also, we set the maximum generated tokens to 50 due to length of the desirable, labels, which I'm going to show you in the next slide, and also the repetition penalty to 1.5, which this number somehow controls the diversity in the output of the large language model. Prompt engineering. We utilize few-shot prompt engineering to get a better result. And for this task, we just feed the model with just one example, which already verified by the expert. And we managed to improve the large language model performance on identifying the relevant records to the suspected suicide. Here is the prompt template that we used. This prompt template adheres to the Llama 2 prompt template. It has 3 sections: system prompt, example prompt, and the instruction. In the system, I think you already know, if you are working with the large language models, you can define a role for the model, and then you provide it with a very precise and exact example about your input and your output. And this is not a real example. Apologies because of that, because I couldn't put it here not to disclose the sensitive information. And in the end, you provide the instruction and the real document to extract the label for this task, which is the labeling. This is the hardware that we use. It is not a very powerful hardware. For our task, it was a shared PC with a limited GPU. And in terms of the software, we use Python 3.11 and transformers for doing prompt engineering and loading a model, and also NLTK for just data cleaning and data preparation. A little bit about the data. Our data set, we had nearly 6,000 records, equivalent to a month of the data for all incidents extracted from Dorset Police RMS. And the data set was not limited just to suicide-related records. It has other incidents, including the reports of custody, burglary, theft, etc. And also the data had several disturbing characters, like these symbols that I put here, which not only make the text hard to read for the human, also it often surpasses the Llama's 2 maximum input sequence, which is the 4096 tokens. We clean the data before sending it to the large language model to get the output. In terms of the finding and conclusion, I'm apologizing for this number that I put here. There was an error on our abstract. When we submitted the abstract, we reviewed the model performance. We did a subjective evaluation. I think in the summary on the conference website, it was mentioned nearly 83%. But the real number evaluation is 76% current prediction identified by the expert. And our approach considerably reduces the time for analyzing the data compared to expert-driven analysis, which was manually, from days to a couple of minutes. And the current approach is applicable to other occurrences, not just the suicide attempts. It's obvious, and we recommend the police and similar organization to use the capability of large language models, similar to the task we explained, to alleviate the workload and pressure on the forces. Limitation of our work, yeah, Llama 2's context length is limited to 4096 tokens, and because of this limitation, we had to sometimes, divide the input prompt into, or the input document into 2, 3, or maybe more sub-documents and send it to the model. And because of that, sometimes the resulting segment had, insufficient content for analysis, which returns irrelevant results, and also model hallucination, which occasionally produces, false negative or irrelevant output. Suggestion for the further work, we think that if we fine-tune the LLM with domain-specific data, it will enhance the model performance even more than the number that we got. And also utilizing large language models with larger context to overcome, the text chunking. And I know that recently they released Llama version 3, which I think it has 8K tokens that would be more than enough for this task or maybe other similar, tasks. We gratefully acknowledge Dorset Police for providing the data which was necessary for this work. And references, and I'm happy to get if there is any questions.
Very much, Ehsan. We've got a few questions coming in on Slido. If anybody else wants to still log some in, a reminder our number is 3716942. But before we turn to those, there is so much going on around use of LLMs, and I feel like lots of people are still kind of discovering these tricks, like thinking about quantization and the strengths and weaknesses of different models and stuff. So it's great to just be sharing in this forum the kind of travails that we're going through. There's obviously still quite a lot of uncertainty at the end of this model. Yeah. So my question is, how are you working with your end user there to make sure they understand that uncertainty and aren't assuming it's better than it is, I guess?
Yeah, of course. Actually, we try to, because our audiences in the organization is usually non-technical users. And we try to, talk about the risk and, the errors that we can find in the large language models, especially the model hallucinations. And it is a back and forth, relationship and iteration, because you need to provide the result for the expert, and expert study the sample of the data and the output, and then it returns, and then it was somehow the way that we went for creating a good prompt to get a better result from the large language model.
Okay, thanks. Let's pick a couple from the Slido as well. An interesting one. I've encountered this in other areas, actually. Did you encounter any pushback from the LLM in you wanting it to discuss suicidal thoughts or suicide as a theme? A lot of these LLMs have controls, don't they, around?
Yeah. Yes. Somehow, if the model encounters, some, offensive words in the text, which somehow happens, it returns, a sentence that I cannot process this, this model, this input document. But I believe there are some uncensored, offline models that you can use them. I've seen a couple of them on Hugging Face. So you can download those models which are uncensored, and you can utilize them if the current large language model doesn't work for your task.
Okay. And we've had a couple of questions in here which are around a similar theme of kind of how did you evaluate the performance of your model when you're making these different choices, like decide, you know, the quantization approach or the decision to use kind of the one-shot prompt? How did you evaluate it?
In terms of the quantizations, we had a limitation about the infrastructure. So we went for a model that we can load it and, you know, do the inference. It was the main limitation. For evaluating, you know, the result, me and my colleague Lee, because he is an expert in this area, we discussed the result of the model of the different approaches. It was, as I mentioned, it was a subjective evaluation. We didn't use any, you know, objective metrics for the, you know, the metrics for classification, the accuracy, or, you know, the other rock area under curve and the other, you know, evaluation metrics. It was totally subjective evaluation, and it totally depends on the, you know, expert, you know, expertise.
Yeah, interesting. I think we will wrap up questions. There are a few more questions on the Slido, which we'll connect to you with.
Thank you.
But thank you very much indeed.